Hey everybody. Today we're going to be taking a very simple Golang microservice and creating a full end-to-end CI/CD pipeline for it using ShuttleOps. This is a very simple Golang application which simply returns the host name of the machine that the binary actually runs on. This actually uses a HTTP framework called Gin, and we can see it in action by running it through our IDE. By default, this particular application listens on port 8080, and we can simply curl it. As we can see, we get our host name, and our application is working as expected. The CI/CD pipeline that we're going to be building is going to be made with ShuttleOps. With ShuttleOps, we are going to create a pipeline that on push to the master branch of our Git repository, there is a trigger that is going to create a Chef Habitat package. This is going to be the build pipeline. And this build pipeline is going to package our Golang binary along with other important information such as the runtime dependencies that our Golang binary needs, and also what the actual execution of that binary looks like. All that information is going to be packaged into the Chef Habitat package, which is an immutable package, which is going to be uploaded to habitat.sh, which is the official public Chef Habitat builder and acts as the artifact store for this particular artifact. As part of our deployment pipeline, we are going to be launching 3 instances, T3 micros to be exact, onto AWS. And all of these instances are going to be behind a load balancer. Whenever we push to Git and our artifact gets built and our artifact gets uploaded to the Chef Habitat builder, it's also going to be linked to the deployment pipeline, which is going to pull, or the instances specifically are going to pull the new artifact that gets uploaded to the Chef Habitat builder, and they're going to run the latest artifact as a service. So when you hit this load balancer right here, you're going to get the latest code from our master branch. To get started, the first thing that we need to do is go to the repository mentioned in this tutorial. The repository name is gshow/zip simple goapp. We can go ahead and fork this repository. I've already done this. This contains all of the files necessary for packaging the application that was visible in the IDE. But if we explore a little bit further, the most important thing that we see in our Git repository in terms of learning how to use Habitat is the Habitat directory. In its most basic form, it contains the plan file and also the hooks directory. The plan file is very, very simple. And the reason being for that is our use of scaffolding. Scaffolding ensures that we only need to specify the metadata for that particular Chef Habitat package. We don't need to specify any of the build phase callbacks, which would be essentially bash functions which exist underneath this metadata. These bash functions tell Chef Habitat exactly how you create how you build the binary and where do you copy the binary and what extra validation steps do you do once that binary is built as part of the Chef Habitat package building process. But the scaffolding, which we specify here in this variable package_scaffolding, takes care of all of that. We can also specify package dependencies that we need at runtime. So in this particular case, we actually need glibc for our Golang binary to work. And we can also enable Golang modules, which are visible here. This is the Golang module that's defined by our application. These are the respective checksums for the Golang module. And if you go back to the plan file, we can also see this particular variable here, package underscore bin underscore dirs. And all this does is it makes sure that anything that is in the bin directory, which scaffolding takes care of, is part of the path when we are using our hooks. So in order for a Habitat package to be able to be run as a service, we just need our run hook. This is a very simple run hook. We can see the shebang declaration right here. And we can see that we're just executing the binary that we've built with the Golang scaffolding in the Chef Habitat package. And we're running the Golang microservice that we saw in the IDE. Since we're already logged into GitHub through our browser, we can simply go to app.shuttleops.io. It'll take us to the login screen where we can use either GitHub, Bitbucket, or email and password to log in. But because we're logged in through GitHub, we can just hit that. Usually it's going to take us through an OAuth authorization page, but that's already been done. So it takes me straight to the connections page in ShuttleOps. The connections page is very important, and it determines our connections to cloud providers. It determines our connections to VCS providers, for example, GitHub, which is already configured because I signed in through GitHub. But it also configures our connection to the Chef Habitat builder, which we mentioned before in the diagram, where artifacts are uploaded to. Additionally, we can also configure Slack for notifications whenever our build pipeline is done or whenever our deployment pipeline is done. But since GitHub is already configured, our next step is to configure a cloud provider. We can choose between AWS, Microsoft Azure, or Google Cloud, but today we're going to be going with AWS. ShuttleOps also includes a CloudFormation link to a template that will create a user, an IAM user for ShuttleOps to use in order to provision AWS resources. It'll create the policy for that particular IAM user, and it's going to fine-grain the policy permissions as much as possible so that ShuttleOps can simply launch the AWS resources that it needs in the deployment pipeline. So this launch stack icon will take us directly to a CloudFormation template. I'm already logged into AWS, so it takes me straight to here. I can just hit next, select this template. I'm not going to change the name. For this demonstration purpose, I'm not going to tag it. But the important thing here is I'm going to be accepting the capabilities. And now I can create it. Once the creation is finished, I'm going to have the AWS access key and secret access key as outputs, which I can later use to configure our AWS connection in ShuttleOps. Once the CloudFormation template is complete, we can take the access key and configure our connection to AWS. I'm just going to name it something simple like AWS and select the region as US East 1. Now, it's important to remember that ShuttleOps does not store these in plain text. It uses encryption both in transit and at rest by using TLS and HashiCorp Vault, respectively. So that way we know that our AWS key, our AWS credentials are secure. So we can just hit save, and AWS is now configured. The next and last step is to configure the Chef Habitat Builder connection. We can hit this link right here after opening up the connection setting for the Chef Habitat Builder, which will take us to the official public Chef Habitat Builder site. We can sign in with GitHub, and it's going to redirect us to the profile page. Here we can see we don't have a token, and we can generate a token and put it right here. But we also need an origin that we'll be uploading our Chef Habitat packages to. So we're going to go to our origins and we're going to create a new one. I'm going to name this something very specific to what we're doing right now. ShuttleOps Simple Go app, and I'm going to leave it as public, meaning anybody can see and download, but not actually manage our Chef Habitat packages on its origin. As you can see, it's an origin, but it's empty. There's nothing in it. So I'm just going to take this name and specify it right here. And I'm going to set this as my default Chef Habitat Builder connection. Now we're connected to both GitHub, AWS, and Chef Habitat Builder. In order to start creating our build pipeline, we simply need to go to the Build tab. We can hit the plus icon to start a new build pipeline. And the first thing we need to do is select the code square right here. It's going to open up and allow us to select the repository. Since I've forked the repository called Simple Go App, I can select it right here. And I'm going to add it. Automatically, it's going to scan the repository and detect that we do have the Habitat directory that we were looking at earlier. And that Habitat directory does have a plant file in it. So we don't need to do anything here. We can just exit out of that. But let's also add a build trigger. So this particular build trigger is going to make sure that every time we push to master, it's going to trigger this build pipeline. This pipeline looks good. All we need to do now is hit launch. This is going to start building our Chef Habitat builder, our Chef Habitat package, and it's going to upload it to the Chef Habitat builder. Once our build pipeline has run to completion, we can see that the artifact that it built has been uploaded to the Chef Habitat depot. We can now go to the Deploy tab and start creating a deployment pipeline. We're going to hit the component selection pane, and we're going to select the origin that we just built against, ShuttleOps Simple Go App. I'm going to select that. This is the variable configuration page, but we don't have any variables defined in a default.toml file in the habitat directory of the repository. So there's nothing to configure here. But we do need to define the AWS components that we're going to be deploying, as discussed in the diagram. So we're going to be deploying to T3 micros. Specifically, we're going to scale this up to 3. If these were standalone instances and we wanted to expose them to a particular CIDR block, we would be creating a security group, but we don't need that because we're going to be creating a load balancer. When you create a load balancer, the security groups get created for you transparently, so you don't have to worry about it. We need to make sure that we define the listener though. We're going to be doing this over HTTP. And whenever we hit the load balancer on port 80, it's going to reverse proxy to the backend instances on port 8080. Sorry, port 8080, not port 80. So we're going to hit the load balancer on port 8080, and it's going to reverse proxy the HTTP request to port 8080 on the backend instances. So this looks good. So we're going to hit save. And the one thing that we do need to do in order to make this a full end-to-end CI/CD pipeline is to ensure that whenever the build pipeline runs to completion, the deployment pipeline also runs to completion. And this will ensure that the latest artifact is going to be pulled down to the instances, and we'll be able to hit that new application logic when we hit the load balancer. So the way we do that is we add a trigger, specifically a pipeline trigger for our deployment pipeline. We're going to link the build pipeline that we just built. And we're going to hit save. And now we can launch our deployment pipeline. Here, our deployment pipeline is going to create the backend instances and also the load balancer. And in a few minutes, we should be able to see all of that. Once our deployment pipeline is complete, we can see in AWS that our ELB is created, and we can actually hit it right here on port 8080. If we want to test the continuous delivery aspect of our pipeline, we can actually push a commit to our Git repository. Here I have added a new endpoint /hello, and all this endpoint is going to do is return a JSON with the key hello and the value world. And because I pushed that commit, this actually triggered a build pipeline run. So this build pipeline run is going to run to completion, and then that is going to trigger a deployment pipeline run. And this will make sure that the new artifact that gets built by the build pipeline run is going to get pulled to the instances. And this particular load balancer is going to have a new endpoint called hello, which currently doesn't exist right now. But as soon as this build finishes and the deployment pipeline build gets triggered or it runs to completion, it will. Once our next successful build for the build pipeline is complete based on our push to GitHub, our deployment pipeline is going to be triggered as well. And we can see that our second build is also successful for the deployment pipeline, which means that this particular ELB is going to have our new endpoint. And we can see that once we go to /hello, we get our hello world endpoint. So we have a full CI/CD solution now that we made using ShuttleOps. Hopefully that shows how to use ShuttleOps to create a full end-to-end CI/CD pipeline for our Golang microservice. If you'd like to use ShuttleOps, just go to shuttleops.io, click the login, and you can log in with GitHub or Bitbucket or an email and password combination, and you can start using ShuttleOps.io today for free.